Welcome to this comprehensive guide on analytics. In today's world, data is everywhere. Businesses, organizations, and individuals generate massive amounts of information every single day. But raw data by itself is just numbers and facts. Analytics is the process that transforms this raw data into meaningful insights that help us make better decisions. Throughout this video, we will explore what analytics is, how data is collected and analyzed, and why it has become so important in the modern world. Before we can analyze data, we need to collect it. There are two main ways to gather data. First, we have primary sources. These are methods where you collect data directly from people or events. This includes surveys where you ask people questions, interviews where you have conversations with them, and experiments where you test something to see what happens. Second, we have secondary sources. These are existing collections of data that others have already gathered. This includes historical records, databases, government reports, and published studies. Understanding which source is appropriate depends on what questions you're trying to answer. Let's dive deeper into primary data collection methods. Surveys and questionnaires are structured forms that collect opinions, preferences, and feedback from a large number of people. Interviews and focus groups involve direct conversations where you can ask detailed questions and understand why people think the way they do. Observations mean watching and recording how people behave or how events happen in real situations without interfering. Experiments are controlled studies where you change one thing and measure how it affects another, helping you understand cause and effect relationships. Each method has its strengths. Surveys are efficient for large groups, interviews give detailed insights, observations capture real behavior, and experiments prove if something actually causes something else. Secondary data comes from many places. Published sources include books, research journals, newspaper articles, and academic reports that already contain analyzed information. Government data includes census records, tax information, and economic surveys collected by government agencies. Online resources are websites, public databases, and open data portals where organizations share data freely. Internal records are documents and systems within a company like sales reports, financial statements, and transaction logs. Industry reports are analysis documents created by research firms about market trends and competitor activities. Social media provides user interactions, comments, likes, and shares that reveal what people think and do. All these sources can save time and money because someone else has already collected the data. After collecting data, we must prepare it for analysis. This is called data cleaning. First, we remove duplicates because if the same record appears multiple times, it will skew our results. Second, we handle missing values because incomplete data can affect our conclusions. We decide whether to remove records with missing information or fill in the gaps with reasonable estimates. Third, we fix errors and inconsistencies such as typos, spelling mistakes, or values that don't make sense. Fourth, we standardize formats so all data follows the same pattern, like ensuring all dates use the same format. Fifth, we remove outliers or unusual data points that might be errors or don't represent the normal situation. Data cleaning can take up to 80% of a data analyst's time because clean data is essential for accurate results. Once data is clean, we need to show it in ways people can understand. Bar charts compare values across different categories, making it easy to see which is highest or lowest. Line charts track how something changes over time, perfect for showing trends. Pie charts show how a whole is divided into parts, like market share percentages. Scatter plots display the relationship between two variables, helping us see if they are connected. Heat maps use colors to show data intensity, where darker or brighter colors represent higher values. Geographic maps represent spatial data by location, useful for showing regional differences. Each visualization type tells a different story. Choosing the right one depends on what story your data needs to tell. Many software tools help create visualizations. Tableau creates interactive dashboards that let users explore data themselves. Power BI integrates with Microsoft products and is great for businesses already using Microsoft systems. Kulik Sense uses special technology that connects related pieces of data together. Domo is cloud-based, meaning you access it through the internet from anywhere. Google Charts is free and web-based, perfect for simple visualizations. Plotly is open source, meaning the code is free for anyone to use and modify. Infogram specializes in creating beautiful infographics and simple charts. Looker focuses on business intelligence for large organizations. Each tool has different strengths, so the best choice depends on your needs, budget, and what type of analysis you're doing. To understand data deeply, we use statistics. Descriptive statistics summarize data using numbers like the average, middle value, and how spread out the data is. These tell you what the data looks like. Inferential statistics go further. They let you take information from a small sample of data and make predictions about a larger group. Correlation and regression analysis help you understand if two things are connected and how strongly. You might discover that studying longer correlates with higher test scores. Hypothesis testing is like asking a question and then using data to see if your answer is right or wrong. It helps confirm if something is really true or just happened by chance. Probability analysis calculates how likely an event is to happen. Together, these statistical tools help you extract meaning from numbers. Data analysts have several key responsibilities. Data collection involves gathering information from various sources. Data cleaning means preparing and fixing that data so it's ready for analysis. Data analysis means using statistical methods and tools to find patterns and trends. Visualization means creating charts and reports that show what the data means. Collaboration means working with other team members to solve problems together. And finally, insights means explaining what the data tells us and giving recommendations about what actions to take based on those insights. A good data analyst is not just good with numbers. They need to communicate clearly, ask the right questions, think critically about problems, and help others understand what data means for business decisions. Data analytics is a growing field with different career stages. Entry-level positions are for those with 0 to 2 years of experience. New analysts learn the basics, work on smaller projects, and earn between 3 to 6 lakh rupees per year. Mid-level positions are for analysts with 3 to 5 years of experience. They handle complex projects, lead small teams, and earn between 6 to 12 lakh rupees per year. Senior-level positions are for those with more than 5 years of experience. Senior analysts create strategies, mentor junior analysts, lead large projects, and earn between 12 to 18 lakh rupees or more per year. Your salary and responsibilities grow as you gain experience and develop stronger skills. To succeed in data analytics, you need both technical and soft skills. Technical skills include SQL, which lets you query and retrieve data from databases. Excel is essential for organizing and analyzing data with formulas and charts. Python and R are programming languages used for statistical analysis and automation. Statistics knowledge helps you understand data and test if your conclusions are valid. And visualization tools help you create dashboards and reports. Soft skills are equally important. Critical thinking means asking good questions and not accepting data at face value. Communication means explaining complex findings in simple terms that others understand. Collaboration means working well with team members. And business understanding means knowing how data connects to actual business problems and goals. The best analysts combine both technical expertise and soft skills. After gaining experience as a data analyst, you have many career paths to choose from. You can move into data science, learning machine learning and artificial intelligence to build predictive models. You can become an analytics manager, leading a team of analysts. You can transition to business intelligence, using data for strategic decision-making. You can specialize in a senior analyst role, becoming an expert in a particular area. You could move into consulting, helping different companies solve their data problems. You can specialize in specific industries like healthcare, finance, or marketing. You can transition into data engineering, building the systems that store and process data. Or you can aim for Chief Data Officer, an executive role managing all data strategy for an entire organization. Each path offers different challenges and rewards, so choose based on your interests and strengths.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.